Welcome, everyone. Today, we will not discuss in depth anything related to LLM training or inference. We will go through a practical application that how we can use RAG and fine-tuned LLMs to enhance our security posture, how to enhance security and any network report generation. So what I will do in this presentation, I will show that how we have integrated RAG and open source model fine-tuned with our OCI Cloud Guard. And I will also show how we are using our Oracle vector search with our Oracle database AI, which has been announced, I think, 1 day or 2 days before, this week. So anyways, let us get into the matter of the things. One of the things, as you may have seen, we have presented in our earlier presentations in ODSC, that we are seeing how the paradigm is shifting the way we do computing. What we are seeing that LLMs are being used as the compute platform, and we as users or even programmers, we are interacting with that compute platform using NLP, using natural languages. And in this presentation, we will show that how we are using open source based LLMs or even closed source LLMs from Cohere or Reka, and how we are using it for our own security report generation. So a little bit of background. Why we need security reporting? What is the necessity of swift and accurate reporting? So one of the main reason for any security incident remediation or a network incident remediation is that a rapid response is required. So as we have seen that in cybersecurity, the speed of a response can be critical. And it is actually as critical as the response itself. So swift reporting enables organizations to react quickly to threats and potentially mitigating the damages before they escalate. So not only reporting is critical, the other item that is critical also is the precision in detection and response. So accurate reports are vital for identifying the specifics of a security threat or a breach, and that ensures that responses are appropriately targeted and effective, and preventing any future occurrences. So what we have seen with these two swift and accurate reporting metrics, it has a huge impact on organizational security. So one of the most important one is avoidance of financial loss. We know that security breach can lead to significant financial losses, maybe because of any potential data theft, disruptions in operations, and of course it can cause a reputational damage. And then the next one is regulatory compliance. Many industries are subject to strict regulatory requirements concerning data breaches. And we here work with healthcare, we work with financial sector, our financial services, and accurate and timely reporting actually helps ensuring compliance with laws and regulations. And we can avoid, or our users can avoid legal penalties and fines. Then the next way this system can help in strategic decision making. It actually enables the management team and the security team to make informed decisions. Detailed and reliable security reports provide insights that are needed to make informed decisions. And then the second one, which it can do, is that it can also predict and prevent any future threat. And what we have done is that we have an ecosystem of AI agents. So we can actually take these reports generated by AI agent or our LLM application in this case, inference application, and we can feed it into another AI model to analyze these reports and then help organization to identify patterns and predict potential future attacks. And in a slide at the end, I will show that what are some of the OCI services we have to build out this agent ecosystem. Anyways, back to the background why we need accurate reporting, because it also enhances trust and reliability. Consistently accurate and prompt reporting demonstrates an organization's commitment to security, and it can build stakeholder confidence. And then, of course, you have internal assurance for any internal teams, whether it is a management team, development team, engineering team, sales team, finance team, especially those directly involved in security and risk management. Accurate reports provide a clear understanding of the threat landscape. And this actually enhances their ability to manage and mitigate security risks. So what are some of the challenges we see in security report generations, even using our everyday AI statistical models? One of the thing is complexity of security data. So what we see that security teams need to process vast amount of data, which can be system logs, which can be firewall logs, switch logs, and these all come from various sources. Then they need to process network traffic, user activities, and any alerts that are produced by the application of the system. And this sheer volume and heterogeneity of this data can overwhelm any traditional processing method. And then the next challenge is the real-time processing need, because one of the things I had mentioned that we need instant or near instant remediation or reporting. So this requirement for real-time data analysis adds another layer of complexity. So security data must not only be collected, but also analyzed and reported, and sometimes used for remediation in near time so that the entire system is effective, right? So what we have seen that this also leads to another set of challenges when we are using an AI model, which is accuracy and contextual relevance. So if you are using manual processes, we find it is to be error prone, right? As we know, many aspects of traditional security report aggregation or report generation involve manual processes, and they are susceptible to human error, other system error, and often result in inconsistencies in reporting. I have seen that we have one set of network report and one set of application report and one set of user activity reports, and if we are trying to aggregate them manually or using some tools for relevance and correlation, most of the time we get an erroneous result, which may be mostly because of human error. That is what we have seen from our experience. And then we have also seen during this correlation activity that we have a severe lack of context. Security alerts without sufficient context can lead to misprioritization of threats. Reports need to include contextual information to ensure accurate threat assessment and effective response. And especially if you are trying to automate this response, you need that context. So what else? What else we see as challenges? One of the thing is scalability issues, and that can be both as keeping up with evolving threats or resources. We have seen that it can be a resource intensive. Maintaining a robust security reporting system can be a resource intensive, requiring continuous updates and expert personnel, which may not be feasible for all organizations. And then the keeping up with the threats, as security threats evolve and become more sophisticated, the tools and processes used to generate reports must also adapt, to all these new threats. And we have seen many organizations struggle to scale their security operations to meet these changing demands, efficiently. Another one of the important aspect I want to highlight as challenge is the integration challenge. There are disparate systems and tools. Security environments often involve a variety of tools and systems, each generating its own data and reports. And integrating these into a coherent reporting system is a significant challenge. And then we all who works in enterprises across all the verticals, we encountered data silos. The existence of data silos within an organization hampers effective security report generation. Without a unified view, generating comprehensive reports that provide real insights can be difficult. So we all know about the regulatory and compliance pressures. There are compliance requirements. Different industries face various compliance requirements that dictate specific standards for data privacy and security report generation. Meeting these standards can be complicated, right? And then you have to be audit ready. Organization must be prepared for audits at any time, which requires maintaining a high level of precision and detail in security reporting to satisfy regulatory scrutiny. And of course, last but not the least, we have technology limitations. We have legacy systems. Many organizations still rely on legacy systems that are not equipped to handle modern security challenges, or even they cannot integrate with newer technologies effectively. So there is a challenge around adaptability to new technologies. What we have seen that there is a significant lag in adopting new technologies that could automate and enhance report generation. And this significant lag may be because of technical debt, budget constraint, or even sometimes resistance to change from within the organization. So what we can do, to address all these things. So one of the things that we are still experimenting with, and it is also in kind of production, is we are using generative AI integrated with our OCI Cloud Guard and other OCI services, including our vector search. And what we are doing is that we have taken open source LLM. We are now using Llama 3, and we are also using Cohere because Cohere is a partner, and we are using what I call RAFT, or what the industry is calling RAFT. It is a mixture of RAG, Retrieval-Augmented Generation, and fine-tuning the LLMs. So let us spend few minutes on what is RAG and what is fine-tuning. And I think that most of the people in this webinar, they know, but I just want to quickly go through that. So RAG. A RAG is a hybrid model that combines the benefit of information retrieval and language generation. So we can use RAG to pull relevant security logs, incident reports, and other contextual data, which it then uses to generate a comprehensive and accurate security reports. So why are we using a RAG? To enhance accuracy by basing the report generation on retrieved data that is contextually relevant to the specific security incident. RAG is actually ensuring that the reports are not only comprehensive but also accurately reflect the true nature of the security events. We know, apart from this, RAG is used to decrease the hallucinations in LLMs, and we have discussed that in an earlier webinar. And also by using a RAG, what we are doing is that we are increasing the speed of report production. So automating the RAG process significantly speeds up the creation of reports, allowing organization to respond more swiftly to threats. And I will also show afterwards how we are actually hooking it up for automated remediation. And by using a RAG, we are making sure that that we are closer to the ground truth, right? Now, what is fine-tuning? So fine-tuning or fine-tuned LLMs are customized versions of general purpose language models that has been specifically adapted to better perform tasks, in our case, in this cybersecurity domain. So we have used Cohere and the Llama2, which is in production. We are now working with the Llama 3, and we have fine-tuned them with historical data or historical security and network data to specifically understand and generate security related contents. Basically, we have changed some of the weights and biases of the model, right? And the benefit of fine-tuned LLMs in security report generation is the contextual understanding and relevance. With RAG, you can throw all the existing real-time data to the model, but you have to make sure that the model is understanding the context. In this case, the cybersecurity domain, right? So fine-tuned LLMs bring a deep understanding of security-specific language and contexts, enhancing the relevance and detail of the generated reports. And then, of course, it also has the ability to handle complex queries. These models are capable of handling complex queries about security incidents, providing detailed and nuanced insights that can inform better decision making. So it is not only going through the RAG, means going through the documents that we provided through the RAG pipeline, but it is also able to add other insights because it has been fine-tuned in this cybersecurity domain. So one of the things that we have seen by combining RAG with fine-tuned LLMs, that we have a synergy. We have created a LLM, which is a tool which is very powerful for security report generation. RAG in one hand provides the relevant data. LLMs, on the other hand, generate insightful, accurate narrative analysis based on that data. So we have some real-world applications, and I will go through a short recorded video, and we will show that some of the stuff that we have done. So I'm just checking on time. Okay, we're good. So some of the future potential of our model. So it is a continuous learning and adaptation. These AI models can continue to learn and improve over time, adapting to new type of threats and changes in the cybersecurity landscape. Say in future, we make this model available, and then you can take this model and then you can fine tune it in your own environment, or you feed data from your own environment so that over time it learns, and then you deploy it for production for inference. And then what we have seen that it can be expanded to other areas, right? Apart from cyber security report generation, we are actually experimenting it to do a real-time threat detection and automated response. So we are hooking up the response with our serverless function, which is integrated with our Cloud Guard, and it can actually do remediation. That is not yet production. It is running in our development environment, or I can say it is for production for some of the internal OCI tenants. We haven't rolled it out. So if we now integrate this LLM with our Cloud Guard, especially with account telemetry and network logs, what are these, right? And any security network professional know about these things, but this is more for our data scientists, for our ML ops engineers. So account telemetry is the data that is collected about user actions and interactions within systems. It can be infrastructure, it can be application, it can be both, and it can include logging times, access locations, and the usage data. And then the second telemetry that we are doing now is role. What is the role in security? This data is critical in identifying anomalous behaviors that may indicate security threats, such as unauthorized access or insider threat, or even privilege escalation. Someone, if they are only supposed to have read access and somehow they got a write access, so we can go back and we can see how they were able to elevate their privilege in the system. So account telemetry is very important in this case of cloud security. And then of course we have the network logs. We can have the raw network data, and these network logs are records of network activities such as traffic data, end-to-end data, from where it originated and where it is terminating, some of the access requests, and actual server communication. What is being transmitted in those network packets? So we can have, we can have all these records if we can capture the network log. And then from the network log, we can actually drive insights that can be used by our security system, because they provide essential information on the flow of data within and outside the organization. And we can use it to detect potential breaches or any unauthorized data exfiltration. So network logs are most important, component of this telemetry. So how we are integrating this account telemetry and network logs, so what we are doing is that to enhance the report contextuality and relevance, we are combining the data sources. So we are integrating the telemetry data and network logs with RAG pipeline, and it helps to create a more comprehensive view of security incidents. This integration actually allows for contextualizing incidents based on user behavior and network activity. And this leads to more accurate threat assessment. Use cases, one of the crucial, use case is that in pinpointing the source of security breach or in identifying a pattern of suspicious activity that might have been overlooked otherwise. So we have actually created honeypots, in a separate compartment in our tenancy where all the resources are, and then we have a separate honeypot TCN, and we have put it in the right Cloud Guard security zone. And when we ran this RAG, with our fine-tuned LLM, we were actually able to identify patterns, much more faster than any other traditional security tools that go through the logs. One of the things I just want to make sure we understand that this tool is for report generation and for remediation. This tool is not for intrusion detection and prevention. It can be augmented with intrusion detection and prevention, but this is not intrusion detection and prevention. So we have to make sure that we keep it in mind. So some of the benefits of integrating telemetry and network logs. Richer data sources lead to more detailed and insightful incident narratives in security reports, which are critical for understanding the scope and impact of those security events. So by integrating telemetry and network logs, you are actually improving your incident narratives. And then the second point is that it also enhances precision in breach analysis. The depth of data available through telemetry and logs allows for a more precise analysis of breaches, helping to identify not just the what, but also the how and the why of security incidents. With the traditional security reporting, most of the time, if it is automated, you get a great what statement. But using LLMs and RAGs and integrating them with telemetry, whether it is user telemetry or the network telemetry, you can actually double click on the hows and the whys of those incidents. So as usual, what we have seen is the challenges, right? What are the challenges in this integration effort, and what are some of the solutions, right? So one of the challenges, as I have mentioned earlier, is data volume and complexity. And our solution addresses the challenge of handling these large volumes of data from diverse sources, and how RAG and fine-tuned LLMs help manage this complexity by efficiently processing and generating meaningful insight from this data. Actually, we are using our Oracle databases, JSON database, which is really fast, in pulling all these various records from various sources, and then of course we are addressing the data privacy and security with our Cloud Guard security zone and dataset, which ensure data privacy and security while handling sensitive telemetry and log data. If we are collecting data from a regulated industry, we have to make sure that how we handle that data, how we process that data, because it must also obey those regulatory standards. And also our Cloud Guard security zone and our dataset ensure how robust data management and security practices are integrated in this overall process. So for automating report generation, we are leveraging AI technologies where automation is the key via RAG and LLMs. Not only speeds up the report generation process, but also ensures that the generated reports are consistently accurate and timely, freeing up security personnel to focus on higher level analysis and response strategies. And one of those response strategy may be how to build more automation, how to build event-driven remediation from these reports to actual actions, right? So examples of automated insights, automated analysis of integrated telemetry and network logs led to quick mitigation of threats or provided new insights that significantly enhanced organizational security. We have measured so far of 14 to 16x efficiencies, but we are still collecting data, and keep your eye out for the announcements or the logs that we will be providing on Oracle site with some of these metrics, what efficiency we have seen. So now, so for the telemetry, we are for both user telemetry and network and security logs, we will be using OCI Cloud Guard, and I have a demo, a recorded demo of that. So one of the things that we are seeing is that with OCI Cloud Guard, since it is already have the data security zone and the data privacy pieces built in, and how to aggregate, network and security logs. So our whole LLM toolset is built around OCI Cloud Guard. And then earlier we were using a open source vector DB, and now we are using Oracle database 23 AI's vector search capabilities. So let me go through the OCI Cloud Guard. So OCI Cloud Guard is a security service within the Oracle Cloud infrastructure, which is designed to monitor and maintain the security posture of your cloud resources automatically. So if you enable Cloud Guard and just configure some of the basic stuff, it will automatically monitor, and not only monitor, it will also maintain. That means it has the ability to remediate your security posture of your cloud resources in your OCI tenancy. So some of the key features include ability to detect misconfiguration at the infrastructure layer, at the platform layer, anomalous activities, any security thread using predefined rules, and machine learning capabilities. So it can actually detect patterns, right? And it itself has the traditional machine learning capabilities where it is learning on its own, and then it is putting them in a reporting it in a sense in a log file, and then we are taking all the log files and running them through our LLM. So we see machine learning in action in two places, which is inside of the Cloud Guard, and another one is in our system, which is external to this Cloud Guard. So the role of OCI Cloud Guard in this security reporting system is threat identification. It explains how OCI Cloud Guard identifies potential security threats and risks by continuously monitoring your cloud environment. And this proactive detection is very crucial for timely and accurate security reporting. And it is also helped, means you can discuss it, that how it can enrich your data with other security information like telemetry and network logs, and it actually enhances the depth and breadth of security reports. It actually provides a more comprehensive view of the security landscape. So we use OCI Cloud Guard to enhance our contextual awareness. As you have seen, the contextual awareness is key in any meaningful automated reporting and any subsequent remediation, whether it is automated or not. So OCI Cloud Guard's ability to correlate events across different cloud services and resources helps in understanding complex attack vectors and patterns, and thus it provides more context in security reports. And then, of course, you can use Cloud Guard for real-time insights, and then integration benefits. We can integrate it with real-time, with streamlined operations, and we can also use its improved response capabilities. 1 minute. So I just want to go over Oracle Database 23 AI overview, because we are actually using it for our object encoding. We are using it for encoding, and we are also using its search capabilities. It has been announced a few days before, I think on Monday or on Friday, I'm not sure, but yeah. So Oracle Database 23 AI offers a powerful and full-featured database experience. So it actually supports all modern data types, including JSON. So if you are getting telemetry in JSON format, you can actually store it here. And it also provides analytics within a single product. So one of the things is of importance for acquiring all this telemetry is the JSON relational duality. So it actually allows data to be treated as both JSON and relational. improving the flexibility in application development. It has AI vector search, which enhances search capabilities within the database by using AI, making data retrieval both fast and relevant. And we also used it in conjunction with our embedders. So I have a slide on that. And then, of course, it has a JavaScript stored procedure, which is not relevant to this discussion. Overall, it simplifies the development process by integrating advanced features that support both traditional and modern development paradigms. It offers a seamless experience with SQL and JSON, boosting productivity and reducing complexity. We have actually a very large security data warehouse or data lake and warehouse for all of our historical data. And now we are moving it into 23 AI so that we can use vector search within the database itself. And there is a free edition. So if you want to try it, it actually provides up to 12 GB of user data, 2 GB of database RAM, and it can give you access to 2 CPU threads. So you can actually try it out in our free tier for a wide range of applications. So if you are using OCI free tier, you will get this configuration for free forever. Okay, I have a Cloud Guard demo, but before going through the demo, what I will do is that I will just go through what we have built out here. So here you can see that we are having the Cloud Guard, service, which is collecting all the data, the network log and the user telemetry log, which we are putting in an enterprise knowledge base, which is actually which is actually OCI Cloud Guard and Oracle Database 23 AI, which is used to process documents. We are using the Llama index from that, and then our RAG pipeline has been built with LangChain. We have embedding model. We are doing document embeddings in our vector DB. Earlier we were using Hudrant, and now we are using our Oracle DB 23 AI. So while it is going there, we are also having the user who is using our chatbot or an web application written on Apex. They are sending the user query or the prompt along with some of the materials here also, which they are actually sending it through the RAG pipeline up there, and they are querying the database, which is actually the RAG documents. It is creating the a response, and that response is fed into the web app or the chatbot as the output to the user, or it is actually fed into another system, which is actually based on our function and which is our event-driven system, which is going back to the Cloud Guard for any remediation. So one branch of it is that where the response is going back to the user, who is a security analyst or a security administrator. She is using some manual processes for remediation, and then what she is doing is invoking those remediation processes. And the other branch is what we are testing out now is fully automated. We are getting the output from the LLM, we are feeding it into the function as a service through another agent, which is another AI model. And then with the function, we are creating a event-driven remediation. So if it is saying that we should need to close the firewall port 8080, I'm just giving an example, it will automatically use Cloud Guard to invoke a recipe which will go out and close the firewall port 8080 for that VCN. So this is what we have. This is our Oracle AI stack. I just want to go through that so that you understand what are some of the stuff we are using. So all the models have been trained or fine-tuned on our AI infrastructure, where we have a super cluster with RDMA network, which can scale from 16 GPU to two bare metal instances of 16 GPUs, A100, H100, or the newer GB200, to up to 32,000. So it is all built on bare metal or virtual machines, and then we are using Kubernetes for orchestration and job scheduling. And we have lock, object, file storage, and HPC file systems to support this massive training. And then on top of that, we have the Oracle database vector search. We have the autonomous database select AI, where you can actually, you don't have to write SQL queries. You can use natural language to create SQL query. We have the MySQL heatwave with vector store and generative AI plugin. We have our data science platform to build out your data science environments. We have native machine learning algorithms in Oracle databases, classification or clustering, both supervised and unsupervised, models. We have MySQL heatwave with AutoML, and then of course we have a standalone data labeling service that can be integrated with any of these, ML and GenAI platforms. On top of that, we have the GenAI capabilities, means the GenAI, which is actually report generation, RAG, and all this stuff. Then we have GenAI agents, where you can actually string together various GenAI models to do a complex task, where each of the GenAI agent is only doing a specific task. We have our digital assistant, which is our chatbot with a native integration to models, to LLMs. We have our speech service. We have our standalone language service, vision service, and we also have a document understanding service, which is now also using our GenAI capabilities. And then in the end, you may have heard about all these Oracle applications like Fusion applications, Fusion Analytics, our NetSuite products, and industry applications, and our AI services are embedded with these applications. They are natively embedded with these applications. Then we have third-party applications where we can actually work with you to embed our AI services into that. And then we have our AI partners and ISVs who are also working with us to automate or to embed their services in all of these products. Okay, I will now go back and run that demo for you guys. And then we can have some question and answer sessions. Are you able to hear?
It doesn't seem to be running yet. Don't see the timer moving.
Okay.
Let's start with creating a new security zone where we can enforce a set of security policies by default. We select the security area in the OCI console and click on Security Zones. We can see all of the security zones that have been created in our tenancy. To create a new security zone, we click on the Create New Security Zone button. We then give it a name, New Maximum Security Zone, and a description. This is a new maximum security zone. We also need to specify the compartment where our security zone will live, along with the corresponding resources that we place inside the security zone. We will place this new max security zone under the root compartment. The new security zone is now active. We can also see that it is protected with the maximum security zone recipe, which is a collection of over 30 security policies that are defined to ensure optimal security posture by default. These policies cover resources like object store, compute, and database, among many others. It also enforces security best practices like encryption and preventing data movement to less secure zones. When we created the security zone, we also created a new compartment to store all of the resources associated with that zone. We can see from the compartment section of the console that I now have a compartment called New Maximum Security Zone. To better understand how these policies are enforced, we will try to create an object store bucket in our maximum security zone. We will try to create this bucket without a customer-controlled encryption key, instead using a service-provided encryption key. When I try to create this bucket, the maximum security zone policy prevents us from creating it. This is where Security Advisor comes to our rescue. We can use Security Advisor to go through an optimized workflow to solve our security problem. We are now in a wizard that guides us through the various steps of creating a secure bucket. The first step is to create a secure vault in our zone where we can store our encryption key. This vault stores the encryption key on a hardware security module that is highly secure and FIPS compliant. The next step is to create the key that we will use to encrypt all data in the bucket. We select secure 256-bit key for this process. We then create the object storage bucket itself using the customer controlled key we just specified. When we are done, we create all of those resources: the secure vault, the encryption key, and the object storage bucket. Now that the object storage bucket is created, let's take a look at it. If we attempt to unassign the encryption key in the bucket, that is also disallowed, as the maximum security zone ensures that we don't weaken the security of our environment. Let's look at how Cloud Guard can help us monitor and protect our entire cloud infrastructure portfolio. Customers typically have a broad global footprint, with some applications running inside of a maximum security zone and others in regular compartments. Cloud Guard allows us to view and act on our global security posture with a single pane of glass. The Cloud Guard console shows us all of the important security information about our cloud topology in one view. We can see that we have an excellent security score and also a low risk score. The risk score gives us a sense of the criticality of the issues, with a lower number being better. Cloud Guard gives us actionable recommendations to address our identified security problems. We spend a lot of time in Cloud Guard to ensure that we surface only actionable problems and not noise. We can see all of our problems broken down by severity. We have 10 open problems in our environment. We can look at these problems by compartment or by region. Cloud Guard gives us a global view of our security posture, and in this case, we have 2 regions, one in London and one in the US. Below, we can also see a map of where any suspicious user activity is coming from. Thankfully, we don't have any at this time. We can also look at the trend of our security score and identify problems over time. As we've been fixing problems, our security score has increased. To see how Cloud Guard monitors our environment, let's look at the detectors that are configured to monitor our environment. Cloud Guard has 2 sets of detectors: configuration detectors that detect changes in cloud configuration, and activity detectors that detect changes in user or environment activity. The configuration detectors monitor for a number of insecure configurations and have predefined severity levels for each configuration error. For example, a public bucket is considered a critical vulnerability. We also cover other security posture violations like key rotation, for example. We constantly monitor user activity on the system. Activity from a suspicious IP, for example, is a critical issue. These configuration and activity detectors combine together to form security expertise. we process these issues through machine learning algorithms and turn those issues into problems that are actionable. We take action on these problems through our responders. Our responders range from making a bucket private to disabling a user and can be set to act automatically or require a human approval. The entire detector, problem, responder framework has been designed to filter out noise and act quickly on security vulnerabilities. Let's take a look at Cloud Guard in action. We are looking at a hacker who is trying to log into OCI using stolen credentials. This hacker happens to also be using an IP proxy via a Tor exit node to try to mask their footprint. Once the hacker has logged in, they typically look for data they can exfiltrate. In this case, the hacker looks across our regions and starts looking in the London region for data. The hacker searches through stores like Object Store to see if there is any valuable data. This hacker looks around a couple of compartments and then navigates to the restricted access compartment. The hacker has found some customer data and a bucket with confidential information. This hacker wants to make this bucket public so they can exfiltrate data. If we were using a maximum security zone for this bucket, this would be impossible. However, Cloud Guard will still help us. This bucket has a number of associated zip files in it, which seem to contain valuable customer information. Cloud Guard detects this problem and fires off an event to us as a security professional. What we are seeing here is an urgent Slack notification that Cloud Guard has sent to us with the fact that a compromised user has logged into the system from a suspicious IP and has also made a bucket public. Once we receive this notification, we as a security professional log into Cloud Guard to view our problem. Our problem count, which used to be at 10, has gone up to 11, with one new critical problem. Our user activity map shows a suspicious user alert in our London region. When we click on it, we are taken to our problem, which is our suspicious user activity that has been flagged as critical. We can look through the user history of access and see that this compromised user is accessing our system from a suspicious IP. To solve this problem, we click the remediate button. We could have configured this remediation to be automatic, but that wouldn't have made for a very good demo. So we must remediate this with our manual workflow. When we click remediate, Cloud Guard communicates with our identity system to disable this user. The identity system has now revoked the user permission. Cloud Guard shows that this problem is now resolved. That takes care of the user, but what about the public bucket? We don't have an open problem related to public buckets, which might seem weird. The reason for that is because Cloud Guard was configured to auto-resolve this problem for us. When we go into our resolve problems for public buckets, we see that our public bucket has automatically been made private. Cloud Guard detected this problem and remediated it in 5 seconds. This is just a small bit of the functionality provided by maximum security zones, secured for cloud environment.
Hello. Okay, I think we are at the top of the hour. So I have answered, all the questions that I could see. If you want to ask me anything, send me emails, and I will be happy to answer.